This video covers the problems on corrosion penetration rate. Even in the previous video, I covered a few problems on corrosion penetration rate. The first problem, I'll take the thickness of a brass sheet of area 400 inch square is exposed to air near the ocean. After 2 years period, it was found to experience a weight loss of 375 grams due to corrosion. If the density of brass is 8.73 gram per cm cube, calculate the CPR in that is Mmpy, and in terms of Mpy. Okay. Here we have to detect the CPR, corrosion penetration rate, in both the units, Mmpy unit as well as Mpy units. So first I'll take the given things. So here the given K value we have to find. So the equation is CPR is equal to K into W by density into A into T. See the K value, if we are expressing in terms of Mpy, then the K value becomes equal to 500, it becomes 534. I'll take here, it is a given, it is in terms of Mpy, here Mmpy. Okay, in terms of Mpy it is 534, whereas Mmpy it is 87.6. Okay, and the other one is W. Here the given 350 gram. Sorry, it should be a 375 gram. 375 gram. So 375 into 100, sorry, into 1000 milligram. Here also 375 into 1000, it becomes milligram. Then density, same. They given 8.73 gram per cm cube. In both the unit it is 8.73 gram per cm cube. Then area. See here, if we express it in terms of Mpy, it should be in the inch square. So it becomes 400 inch square. In another unit, that is, we have to express in terms of Mmpy, then we have to multiply this quantity 400 into 6.25, then it turns to cm square. That is 1 inch square, sorry, 1 inch square equal to 6.45 centimeter square. 6.45 centimeter square, that I apply. Then time here after 2 years. So here 2 years means 2 into 365 into 24 hours. Okay, in both the case we'll use expressing. Now I'll just substitute these values. So CPR equal to K 534 multiplied by 375 into 1000 divided by 8.73 into 400 into 2 into 365 into 24. So first I can get CPR in terms of Mpy, because I put 534. So 534, it is in terms of, we express in terms of Mpy. So it becomes 3.27 Mpy. Okay, same way, if I want to calculate CPR in terms of Mmpy, it should be 87.6 K, and 375 into 1000 divided by 8.73 into 400, and I should multiply by the conversion factor 6.45 into 2 into 365 into 24. So CPR, if I want to express in terms of Mpy, the CPR becomes equal to 0.083 Mmpy. This way we can able to solve CPR in different unit. Either you can express in terms of Mpy or it may be expressed in terms of Mmpy. Okay, then next problem. Calculate the CPR in both Mpy and Mmpy for a thick steel sheet of area 100 inch square, which experiences a weight loss of 485 after 1 year. This problem is similar to the previous one. Here you have to calculate a CPR in Mmpy and Mpy unit. The given weight loss is 485 gram after 1 year. Okay, so first I'll calculate in Mpy unit. Okay, see CPR equal to K into W by density into A into G, that is equal to 534, okay, equal to 534 multiplied by W. 485 gram should be converted into milligram divided by density 7.9 into area 100 into experiences 1 year, that is 365 into 24. So that the CPR becomes equal to, I'll multiply this one so that I can get. So after calculation, I got 37.42 for Mpy. So in terms of Mmpy, so CPR becomes equal to 87.6 into 485 into 1000 divided by 7.9 into 100. It is in an inch square, converted to centimeter square, so that it becomes 100 into 6.45 into 365 into 24. So after calculation of this, I got 0.9518 Mmpy. This is a CPR. Next one, a metal of iron, a metal iron plate was found in a vessel containing acidic media. It was estimated that the original area was 20 inches square, that approximately 1.2 kg had corroded. Assuming a corrosion penetration rate of 400 Mpy for this iron in acidic, calculate time in years. Density of iron is 7.87 gram per cm cube. In this problem, the given the corrosion penetration rate. They given the corrosion penetration rate, you have to calculate the time, and it should be expressed in terms of years, not they asked in terms of years, not in terms of hours. So first of all, I'll take CPR. CPR is equal to K into W divided by D into rho into A into T. Therefore, we can write T is equal to K into W divided by D of density into density A into CPR. Now, I want to calculate T, so K value, and here the area is expressed in terms of inch square and 400 Mpy, so that the K value becomes equal to 534. So 534 into W, that is 1.2 kg, should be converted into milligram. So first I converted into gram, then I converted into milligram. So that's why I multiply by 1002 times, divided by the density 7.87 into area. Area they directly given in terms of inch square, 20 inch square, into time. The period you have to calculate in that place CPR. CPR is 400. So the time taken to decay this metal is 10. After calculation I got 101. 77.89, 10177.89 hours, but they asked to express in terms of years, so that's why the T value should be divided by 365 and should be divided by 24. 365 into 24, I got 1.16 years. Okay, this way we can able to calculate the time required to decay that particular metal, and with the corrosion penetration rate of 400 Mpy. Now, a piece of corroded aluminium plate. A piece of corroded aluminium plate was found in a submerged ocean vessel. It was estimated that the original area was 64 centimeters square, that approximately 350 grams had corroded away during the submerization. Assuming a corrosion penetration rate of 2.4 Mpy for this alloy in a seawater, estimate the time in years, and given the density of aluminium is 2.7 gram per cm cube. Here also you have to calculate the time required to decay that particular metal. And the one thing is, here they expressed the area in terms of centimeter square and the corrosion rate in terms of Mmpy. That is Mmy. Okay. So the unit is same unit. If they express in terms of inch square, then you have to convert into centimeter square. Then you have to calculate T value. So CPR is equal to K into W by density into A into T, or T is equal to K into W by density into A into CPR. So T value is equal to, here it is in terms of Mmpy, so that 87.6 it becomes, and 350 gram should be converted into milligram, multiplied by 1000, 350 multiplied by 1000. Density is 2.7, area is 64 centimeter, and CPR given is 2.4. And we'll get the time is 73,929.39 hours. So this one you have to change into the time T should be changed to year. So 73,929.39 divided by 365 into 24. So this much of year, that is 8.44 years it is. Okay. Say that particular metal undergo corrosion with a penetration of 2.4 Mmpy with 8.44 years. Now, the one more here. Alloy bronze was exposed to different corrosion environment of area 50 centimeters square for a period of 6 months. Here they used three different media. The bronze alloy was loss of weight in acidic medium was 200 gram, in neutral 120 gram, and in basic medium it is 48 gram. and you have to calculate CPR in Mpy unit. Okay, so in Mpy, if you want to calculate it in terms of Mpy unit, then the area should be in inch square. What the area given here, it is in terms of centimeter square. So you know 1 centimeter square is equal to 0.155 inch square. Okay, you have to take this changes, and here I'll take first CPR equal to K into W divided by density into area into T. At particular uh, medium, that is at acidic medium, first I'll take acidic medium. In acidic medium, okay, in acidic medium, CPR becomes equal to K, that in acidic medium, K value, it is in Mpy 534 into W, they given 200 gram at acidic medium, multiplied by 1000. So it becomes milligram. Then density is 8.73 into, and you have to express the weight loss or the area taken, it is in a 50 centimeter. You have to convert into inch. 50 into 0.155 into the time period is a 6 month. So 6 into 30, number of days into hours, 24. So CPR now it becomes 365.40 Mpy. Okay. If the medium is acidic, the loss of metal is 200 gram. If the medium is neutral, the loss of metal is 120 gram. So in the neutral medium, so CPR equal to 534 into the loss of metal is 120 grams. So 120 into 1000. The new denominator is same. 8.73 into 50 into 0.155 into 6 into 30 into 24. So CPR in neutral medium, it becomes 219.24 Mpy. Then they given one more in basic medium. So in basic medium, the loss of metal what we observed is 48 grams. Okay. Say CPR equal to 534 into 48 into 1000 divided by 8.73 into 50.155 6 into 30 into 24. So CPR now in neutral medium, it becomes 87.70 Mpy. So this way we can able to calculate the loss of metal and the corrosion penetration rate in different medium. Okay. Then here, at two different temperature, you have to calculate the loss of metal. So, he given a zinc rod is dipped in a sodium chloride solution of area 20 inch square, each at different temperature. The metal zinc undergo corroded of 50 gram at 338 Kelvin, 30 gram at 323 Kelvin, and 10 gram at 300 Kelvin over a period of 1 month. Determine the CPR in terms of Mmpy. So, if you want to express in terms of Mmpy, then area should be in terms of centimeter square if the unit is Mmpy. So, here the 1 inch square should be converted into centimeter square. That should be multiplied by 6.45 centimeter square. So, CPR now equal to K into W divided by density into area into T. So that is equal to, you have to express in terms of Mmpy. So it is 87.6 into the W, the weight loss at a particular temperature at 338 Kelvin is 50 gram. That should be multiplied by 1000. So convert into milligram. The density is 7.12 multiplied by the area. Area is 20 inches square. Should convert it to the centimeter square multiplied by 6.45, and the time period is 1 month 30 days multiplied by 24 hours. So that at 338 Kelvin, CPR becomes equal to 6.60 Mmpy. The unit is Mmpy. The same way we can calculate the CPR at 323 Kelvin. That time the loss of metal is 30 gram, and 300 Kelvin the loss of metal is 10 gram. So we can calculate like at 323 Kelvin W becomes 30 gram. So CPR becomes 87.6 multiplied by 30 multiplied by 1000 divided by 7.12 into 20 into 6.45 into 30 into 24. That time we'll get 3.97 Mmpy. For 300 Kelvin, after substitutions in place of W, it becomes 10 gram, we'll get 1.32 Mmpy. Okay, this way at different temperature, the temperature also affects on the corrosion penetration rate. As the temperature increases, the loss of metal increases, the corrosion penetration rate increases. So I'll discuss how the corrosion penetration rate affects the pH with the change in the pH. Say a copper plates of length 2 cm and the width 5 cm were kept in a salt solution of pH 3. Loss of metal was 1 gram. At pH 8 of the solution was 0.8 gram, and at pH 12 of the solution was 0.2 gram in 1 year of a period. Estimate the CPR of copper in terms of Mmpy. Here the unit should be in terms of Mmpy. If the unit is Mmpy, the area should be in terms of centimeter square. Mmpy unit, so the area should be expressed in terms of centimeter square. It is already in the terms of centimeter square. So we can calculate CPR using this formula. CPR is equal to K into W divided by D of rho into A into T. First I'll take at pH 3. So at pH 3, see the W becomes equal to 1 gram. So CPR equal to, and you have to express in terms of Mmpy. The K value becomes 87.6 into 1 into 1000 divided by, we have to take the density 8.96 multiplied by area 2 centimeter into 5. Okay, both are in the centimeter, so multiply, you get centimeter square. The area A becomes equal to 2 centimeter into 5 centimeter, that is equal to 10 centimeter square. That becomes equal to 10 centimeter square, and the period is given 1 year, so 365 days into 24. So the CPR value becomes equal to 0.112 Mmpy. Okay, this is a loss. And now I'll consider for the pH at pH 8. So the CPR equal to 87.6. The loss of metal is here 0.8 gram multiplied by 1000 divided by 8.96 density into 10, that is area, multiplied by 365 multiplied by 24. So at the pH 8, the value becomes 0.09 Mmpy. Then in the medium, the basic at the pH 12. At pH 12, so CPR becomes equal to 87.6 into the loss of metal, what we observed is only 0.2 gram. at pH 12 because most of the components get deposited, and that deposited product itself acts as a protective layer and prevent for the loss of metal. So density is this one 8.96 multiplied by 10 multiplied by 365 into 24. So that the CPR at pH 12 becomes equal to 0.022 Mpy. Okay, so this way we can able to calculate how the pH decides the corrosion rate. Then estimate the corrosion periods in years of a metal tin bar exposed to environments of summer. The surface area of 20 inch square, 0.8 Mpy of CPR with a loss of 730 milligram tin. The density of tin is 7.31 gram per cc. You have to detect the time period for the loss of metal around 0.8 Mpy. So here the unit expressed in terms of Mpy and the area should be expressed in terms of inch square. So the CPR equal to K into W divided by G of rho into A into T. Therefore, the T is equal to K into W divided by T of rho into A into CPR. So the T becomes equal to K. Here it is expressed in terms of Mpy. So K is 534 into the W, that is loss of metal 730 milligram. They given in terms of milligram. So you have to put it just 730. Then 7.31 is a density. Area is 20 inch square. Then the time period, in that you have to calculate time period, and they given the CPR 0.8. So that the T becomes equal to 3335.93 hours. But they asked to calculate in terms of years. So T is equal to 3335.95 0.93 divided by 365 multiplied by 24. That becomes 0.38 years. So this much of time taken to decay that particular metal. Then here the another a piece of corroded steel plate was found in submerged ocean vessel. It was estimated that the original area was 10 inch square. The original area what is observed is only the 10 inch square, that approximately 2.6 kg had corroded. 2.6 kg had corroded away during the submerization. Assuming a corrosion penetration rate of 200 Mpy for this alloy in seawater, estimate the time year density of steel, the given 7.9 gram per centimeter or cc is given. Here we have to find out the time taken for the decay of the particular metal. And they expressed it penetration rate in terms of 200 Mpy. How to keep it in terms of Mpy only? So CPR becomes equal to K into W, density into A into T. Therefore, T equal to K into W by T into rho into A into CPR. That is K, you should take it in terms of Mpy, so it becomes 534, W 2.6 kg, so gram, 1000 multiplied by 1000 to becomes milligram. Then density 7.9 multiplied by area 10 inch square, because it is in the Mpy unit, 10 inch square multiplied by the time period. You have to find, and the CPR given is 200. Okay, so you will get time period in terms of years. Okay, we get time in terms of years. Once you get the value time in terms of year, you have to After substitution and calculation, we'll get the time in terms of hours, that is 87,873.41 hours. So this hours should be, you have to express in terms of years. So that term should be divided by 365 and the 24. So we'll get time in hours is 10.03 hours. Same way we can calculate, one more thing, we can calculate the CPR in both Mpy and Mmpy for a thick steel of area 100 inch square, which experiences a weight loss of 485 gram after 1 year. So in this, you have to calculate the CPR directly in MMPY and MPY unit. So CPR equal to K into W divided by density into area into time. So first I'll calculate in terms of what inch square is given. So I'll calculate in terms of Mpy unit. So in terms of Mpy unit, so I'll take K value. If I want to calculate in terms of Mpy unit, it becomes 534. W is 485 divided by 7.9 multiplied by 100 inch square into the 1 year, that is 365 into 24. So I'll get 37.424 Mpy. And same way CPR in terms of the other unit 87.6, sorry, here it should be multiplied by 1000. 485 multiplied by 1000 divided by 7.9 into 100. Here you have to put a conversion factor 6.45. So 1 inch square equal to 6.45 centimeter square into 365 into 24. So I'll get 0.9518 mm. This is the answer that I get. You can calculate in both the unit MMPY as well as MPY. What is the things we observed to express in terms of MPY and MMPY is, if you want to express in terms of MPY, then K value is 534. If you want to express in terms of MMPY, then K value is 87.6. And if you want to express in terms of MPY, the area should be in terms of inch square, and in case of MPY, should be same square. All other things are same. Thank you. Kindly watch videos, subscribe, like and share among your friends so that it can help to others.